we've made a model of Turner Falls out of a cake. It's a special cake. It has a base of brownie with a layer of icing and cake on top. That's the foundation of our Turner Falls Park. On top of that is a soft layer. Here we use ice cream. And on top of that, a little bit of sugar. And on the very top, we make the hills and valleys of Turner Falls out of rice cereal. This is the model that we'll use to demonstrate the difference between a normal waterfall and the falls at Turner Falls. We've got our model of Turner Falls ready to demonstrate what a normal waterfall does. What we're going to do is pour water on the waterfall, and the water will flow over the edge, dissolving the middle or softer rock and eroding it away. The upper harder rock will then collapse and fall into the gap, forming our waterfall. As I continue to pour water, the water will erode the top layer and the middle layer, and the whole waterfall will migrate backwards upstream towards me. As I pour water, the water actually starts to dissolve and erode the grains, so you'll start to see grains pop out. We form the nick point, which is the beginning of our waterfall. And as we move the water back, you can see the top is starting to erode and move back towards me. And so the waterfall actually starts to migrate upstream. So as we continue to pour the water and continue to work the stream back uphill, you can see that a canyon forms. This is usually where a small pond or collection area forms at the bottom of a pool, like at Turner Falls, where many visitors come on a hot summer day and go swimming in the cold mountain stream waters. So you can see here our model has definitely eroded out and formed a small valley at the base of our waterfall, which now, if a stream was flowing, would be occurring right here. This is called the nick point of the waterfall. And if we continue to run the simulation, this would migrate all the way across the cake. Unlike normal waterfalls, like on our model here, where the stream and the waterfall actually erode back uphill, at Turner Falls, because of the chemistry of the water and the calcium carbonate that comes precipitating out as that spring encounters that cliff, we get a different type of waterfall, one that actually forms new rock and grows with time into the valley, much like a flowstone would do in a cave. Over time, as water flows over stone, it leaves a layer of calcium carbonate. The same thing happens at Turner Falls. As the stream waters flow across the landscape, they pick up calcium carbonate, and as they precipitate it, they form the waterfall at Turner Falls. Today we're going to use icing to represent that new rock that forms at the edge of the waterfall. So as I pour the icing, what you will see are thin ribbons of calcium carbonate that form, and they grow outwards. They fill in the valley with rock, and actually as they pour off the edge, and this hardens, this icing hardens, it will actually make this model grow further out into the pan. This is what happens when you have a supersaturated fluid, like in a stream, and mineral is precipitated as that water moves out over the edge of the waterfall. So now that we've allowed this to thicken, now you'll see that the density of the fluid on top is heavier, so it'll move more slowly. And you can see the flowstone-like effect. Each layer of icing is like a thin layer of new carbonate rock that's precipitated on the rocks and the twigs and the sticks and all of the things at the Turner Falls Park area. So as you can see, Turner Falls is unique in that the saturated waters that contain all of the mineral calcium carbonate produce a unique waterfall that actually grows into the valley, whereas most normal waterfalls do not. So it's a really unique, great place to go and see geology in action here in Oklahoma.